Alright, let's look at another hydrate problem. So here we have the hydrate of sodium carbonate. We have the initial mass, 8.85 grams. It tells us how much mass is lost when we heat it. We can certainly find out how much is left by subtracting. Find the formula and the name. So we're going to first find the mass of the anhydrous, i.e. dry sodium carbonate. And then we're going to need the molar mass of sodium carbonate. And then we will convert our masses of salt and of water to moles, take the mole ratio, and that will tell us the formula and the name. So let's get started here. The first thing we want to do is find the mass of the dry salt, or anhydrous. So that's going to be 8.85 grams minus 1.28 grams, and that's going to be 8.85, 1.28. This is so annoying. I'm using my phone as a calculator, and every time I do a calculation, an email comes in, and I have to wait for it to go away so I can see the display. Okay, so the mass of the anhydrous salt is 7.57. The mass of H2O is 1.28 grams. So we now want the moles. I guess we need the molar mass. To get the molar mass, we need to know the formula. What's the formula of sodium carbonate? Well, we have to go back and think about the ions. So if we look at our periodic table, sodium is here in group 1. So sodium is going to form a +1 ion. And carbonate, if we look on the table of ions, which I don't have in front of me, but I happen to know it, has the formula CO3 with a charge of 2-. So in order to have equal amounts of positive and negative charge, we're going to have 2 sodium ions for every carbonate ion. So that means the formula is going to be Na2CO3. Okay, so the molar mass of sodium carbonate is going to equal 2 times the molar mass of sodium, 22.99. Plus the molar mass of carbon, which is 12.01, plus 3 times the molar mass of oxygen, which is about the most memorable on the periodic table, 16.00. There should be an end parentheses there. All right, grab phone. What do you want to bet? Another email will come in while we're doing this. 22.99 times 2, add 12.01. Okay, that looks like, can that possibly be right? Yeah, maybe. 105.99 grams. All right, so now let's find our moles. We have 7.57 up here grams of Na2CO3. We're going to multiply that by 1 mole. Divided by 105.99 grams. And we have 1.28 grams of water. And we're going to multiply that by 1 mole of water. Has a mass of 18.02 grams of water. And now quickly we will do these. 7.57 divided by this gives us 0.0714 moles of sodium carbonate. and 1.28, 18.02 gives us 0.0710 mole H2O. That sure looks like 1-to-1. I could calculate that if you really wanted me to. And I get 0.994, so that's 1. So our formula is going to be Na2CO3 dot H2O, 1 H2O, and we're going to call that sodium carbonate monohydrate.